In this example, we're going to program a simple lathe part. We're going to use an imported file to do this. The part that you use can also be drawn within Bobcat or imported from another system. We're going to open up the advanced turning tutorial, and that brings in a SolidWorks part file. You could see that the part is not orientated to the coordinate system or to the zero axis in the way that we need to machine it. We need to line this part up with the axes the way that it should be. Let's go ahead and turn on Lathe Mode. So we'll go to Preferences, Settings Part, and then Units, and then we'll turn on our lathe coordinates. Now if you're using your lathe in diameter mode, you can change the drawing coordinates to also reflect that by clicking on Lathe Diameter Mode. We'll go ahead and press OK, and you'll see the UCS icon changes to then align the X and Z axis the way it would be on a CNC lathe. Let's go ahead and orientate the part to that position the way it would be cut. Now since this part's already at 0, we'll just simply have to rotate it. So we'll go to Utilities, then Rotate, then we'll select the model and right click and left click OK. We're going to change the origin to XYZ0 and turn it on to Enter, and then we'll rotate about the X-axis 90 degrees. And that'll flip the part over. We can see the preview here. So once the part is previewing the way that we want it to, we click OK, and then cancel. That moves the part. Now since this is a 3D model, we need 2D edges to work with for the lathe. So to do that, what we're going to do is create a surface that intersects this model and then work with the curves that we can generate from the intersection. So we'll come to Surfaces, Rectangular Plane. I'm just going to make this larger than the model. Let's say we make it 20 by 20. Now we have a plane going through the model. We'll press OK and then cancel. And what we need to do is get the 2D geometry that intersects between the two. So we'll go to Surfaces, Intersection Curves, then we'll pick the plane that we had created and then choose the solid model. Now you won't see any real changes at this point, but what we'll do is we'll hide the surface, so we'll choose blank, or we can go to View and then blank, and we'll just hide the surface and the model. Then right click and left click OK. This leaves us with the intersection curves. Now to program the part, we only need to work with the radius or one side of the extracted edges. So what we'll do is we'll come to our selection mode. I'll select this shape and push delete on the keyboard. Now that we have a shape to cut, we're ready to come to our cam tree. So we click on cam and then come to our turning stock. The first thing to do is to set up the stock that we're going to be cutting this out of. So we'll right click on turning stock and left click on edit. Now the lathe does not have automatically calculated feeds and speeds. So you can choose the material, but for the calculations of feeds, this will not make a difference. So we'll set the face in Z at 0. Our cutoff point would be at -4 inches. So let's make that -4. We'll say that our end of stock is also at -4. Actually, let's go -4.5. The stock's diameter, we'll use 4-inch stock. And let's say that there is no internal diameter. If you already have an internal diameter, you can specify it here. We then set up our clearance planes and choose OK. Once we've done this, the stock has been defined. The next step is to come in and start to add toolpaths. So let's say we want to rough turn the OD of this lathe part. and use a grooving cycle for this smaller notch here. To do this, we will need to join the line going across so that the tool doesn't dip down into the groove. So let's go ahead and do that. We'll come to Utilities, Trim, One Entity. We'll pick the line to trim and then the line to extend it to. Now we have a line that runs all the way across in the front of this part. We'll be able to use this for a turning cycle now. We'll come to our cam tree, right click on turning stock, go to turn, let's go ahead and choose rough. This loads the feature rough to the machine setup. We'll then select the geometry that we're going to cut. So we right click on geometry, left click reselect, and then pick the shape to cut. In this case it's going to be this chamfer here, continuing through this line all the way to the end, and then we'll hold shift and pick the last line that we want to cut. Then we'll right click and left click OK to confirm our selection. We can then go to rough, right click and go to edit. This will bring up the toolpath settings for the turning. Under posting parameters, you can choose to use separate moves or canned cycles. If your machine supports canned cycles, this is always the better output to choose. It makes a shorter program. Under cycle type, we choose if we're turning or facing. In this case, we're going to do a turning operation. The turning operation can do both a rough turn and a finish turn. Let's select that. The depth of cut is depth of cut per pass, and then any allowance values that we're going to leave for the finish pass. Our stock diameter carries over from when we set up the stock. You can change this value here if you've already machined the part down to a smaller diameter. You can use either system compensation or machine compensation. Machine compensation is always better to use when possible, because if you change your tools, then you can still use the toolpath that's been generated. Come to our rapid moves. The default rapid will usually work for the way that you need it to after cutting a part. You can also be very specific and choose to either move in X then Z, or Z then X, or take an angled move in Z and X at the same time. The choice is up to you. We'll come to our leads, and this is where you can add an extra lead in, lead out length for approaching the part where the cycle starts, so that you don't have to draw the added geometry. We'll come to our tool. Now, the tools in Lathe, you can set up a tool database and then select from your list of tools. You can also enter the sizes on the fly. In this case, we'll take the default tool nose radius and cutting angle. You'll see the theoretical point, or the tooltip cutting point, is automatically calculated by the software. We'll come to our orientation. The orientation for an outside cut would be a 1 or a 2. For an ID cut would be a 3 or a 4. The machine info is the offset number and the turret position, so you can use this to set up your tool number. The home position that the tool returns to after making the cut is also specified here. You can choose RPM, or constant surface feed, and then set your RPM value and your feed rate. You can also specify the spindle direction, either go clockwise or counterclockwise. We'll come to our finish tool and also use the default tool and fill out our surface feed. Once we've completed that, we can click OK, and then it calculates the toolpath. Let's go ahead and create the grooving operation. So we'll come to turning stock, right click, choose turn, then groove. Underneath feature groove, right click geometry, choose reselect, and now we'll pick this U shape for grooving. Right click, left click OK to confirm, and then we'll proceed to edit the grooving operation. Again, separate moves or canned cycles, which we'll choose the canned cycle output. And then we'll do a turning rough, just a single cut. And we'll turn off the system comp. The step over value is the value that the tool moves over in between cutting down. The allowance values leave room for a finish pass. In this case, we'll go ahead and leave no allowance. We can change the stock diameter to account for the fact that we've already removed some material. We can set our pecking amounts for pecking the tool, and any clearance values and retract values. We'll come to rapids. In this case, we'll take the default as well. And leads if we want to use additional lead in, lead out on the grooving cycle. And we'll come to our tool, and we'll specify the tool's width and its orientation, and the tool number and home location, and our spindle speeds and our RPMs. We'll choose OK, and then the toolpath is calculated for the groove. Once you've created your lathe program, at this point you're ready to either come in and simulate. We can do that by right-clicking turning stock and left-clicking simulation, and then clicking the play button to see the simulation. You could set the simulation to either move the part or the tool. After you've simulated the part and the part looks okay, you're ready to come in, underneath Cam Part, click the plus symbol, right-click on Turning Tools, and then Post, or post and save the program.